All right, so we're going to start by writing the equation of our first exponential decay function. So notice that compared to the other graphs that we looked at 2 days ago on page 50, they were increasing, but our exponential decay functions are going down. They're decreasing. So another word for this word decay is decreasing. The graphs are going down from left to right. So our first graph is given by the equation f of x is equal to 1/2 to the x power. So going back to page 50 for a second, we had equations where our lines were going up, they represented exponential growth, and our b values were greater than 1. So this b value was 2, this b value is 2, which means our graph increased. But in this equation, our b value is 1/2. And since that number is less than 1, that means our graph is decreasing. So just like we did for the other graphs, we're going to identify our domain, our range, our y-intercept, and our asymptote. So we're going to identify those 4 features for this one graph. So I'm going to get a highlighter. If you guys want to get a highlighter out of the black caddies, that's fine. So I'm going to do my domain in yellow. So my domain is from the left side of the graph to the right side of the graph. And notice when I make both of those highlights, my highlighter is touching the arrow. So anytime we're touching an arrow, that means our graph goes on forever. So it goes on forever to the left, negative infinity, and it goes on forever to the right, positive infinity. So our domain is all real numbers, negative infinity to positive infinity. So remember, our range is the y values. So I'm going to do the range in a different color. So we go from the lowest part of the graph, which is not technically just on the arrow. It's that whole line is the bottom of the graph. And then the top of our graph, the highest y value, is on an arrow. So the lowest y value is at the number 0, and the highest y value is on the arrow, which means positive infinity. So the graph starts at 0, it doesn't ever go below 0, but then it goes up forever, so up to positive infinity. So our domain and our range are different for these examples. Okay, my y-intercept, we'll move on to the y-intercept next. The y-intercept is the point on my graph where it touches the y-axis. So we're going to go ahead and put a point right here on this graph where it touches the y-axis. And we're counting by 5s, so it's below 5. That would equal 1. So our y-intercept is the point 0, 1. And something that we can notice is that our y-intercept is always our a value. So technically a is equal to 1 since there's no number there. And then that becomes our y-intercept. So that's just a little piece of information that might make your life easier. If you know what the a value is already, then you know what the y-intercept is. And then the last one is the asymptote. So that's our line that our graph sits on top of. I'm going to change my color to green because this green line where my graph is never going below, that's my asymptote. So that's our y equals 0 is our line that our graph sits on top of. So that's kind of the definition of an asymptote, is the line that the graph sits on top of, which is that green line, which is the bottom of my graph. All right. Now let's look at the second one. So we've got another decay because it's going down. And the equation that we can use for this decay is f of x equals 3 times 1/2 to the x power. So a couple different things that we can identify here. So our b is also 1/2 for this equation. It's the base of the exponent, the number with the x. That's our b value. So that confirms that our graph is not increasing, it's decreasing because it's going down. And we'll come back to this, but a is equal to 3. So that might help us identify one of our key features. So we'll start with domain, and then we'll do the range, and the y-intercept, and asymptote again. So these are the key features that you are identifying on the practice that went along with page 50. And that same practice, you're going to do the even numbers as your practice for page 52. All right, so we'll start with domain. So I'm going to change my highlighter to yellow. I'm going to do my yellow highlights for the domain. So from left to right, so here's our left, here's our right. You should notice that my left and right highlights are on arrows, which means it goes left forever and right forever. So my domain is from -infinity to +infinity. It's all real numbers. The graph goes on forever in both directions for the domain. All right, range, I'm going to change my highlight color. So I'm going to go from the bottom of the graph, which is this whole line down here, doesn't go past that line, and then the top of the graph, which ends up on an arrow. So the bottom of my graph is at 0. I don't go below 0. That's the lowest y value. And then my top highlight, that graph goes on forever in the upward direction, so it goes on to +infinity. So again, notice that your domain and your range are different. So if I circled any of the questions or any of the answers on your paper from page 50, that might mean that you need to change your answer. All right, so we'll look at the y-intercept. So I said that we would come back to this. So we said that the a value is our y-intercept, which I can confirm looking at that graph that the y-intercept is 0, 3. So you have two ways of identifying your y-intercept, by looking at your a value or by looking at your graph. And then this green line, that's our asymptote. It's the line that the graph sits on top of. That is 0 again. So y equals 0 is my asymptote. So you're going to identify the same 4 key features for the 4 graphs on your page 52 practice.